In this video, we're going to create a melee script for a top-down character controller. Now, I'm going to keep with the theme of having all these videos be independent, unrelated to the other video sort of thing, because I don't want to assume any knowledge. Like if you watch this video without watching the other video, that's fine. But in this case, I'm not going to talk about top-down movement in this video because there's another video for it. And this video is very much like related in a lot of ways. So if you don't have the top-down movement yet, I do recommend watching that video. We're still going to make a separate script, so it's still not technically 100% related. Like you could make this video without making a character that moves at all. It wouldn't make a lot of sense. Anyways, let's go make it. So this is going to be a top-down like melee script. We're going to use something called box casts. Okay, again, we're going to go with the whole no prior knowledge thing. So first thing we need is make a script that we can use to control our player's attack. We're also going to need to use the input system for this because this is something that uses inputs. So the first thing I want to talk about is the input system. Now this is actually using the Unity 2D template from the class. So input system package is built in by default. And if you're using Unity 6's default templates, it should be there as well. Input systems actions right here. This is all of the things you can do with your character in the game. Let's open up real quick. Input actions, the first thing let's see is action maps. These are the things you can control in your game. We can control our player, we can control our UI. And then each action map has multiple actions associated with it. These are the things you can do. Our player can move, can look, attack, interact, crouch, jump, previous, next, it's like UI related stuff kind of, and they can sprint. For our UI, we can do a bunch of other things too. So in this one, we're going to use the built-in attack thing. I'll show you how to change it real quick because, for example, you might not like that it sets a button west by default. You can click where it says path here and click listen and press a new button you'd like it to be. For example, P on the keyboard or the south button of the gamepad, and then just click on it. I'm going to keep everything as it is by the default. You can also click plus to add a new one if you want to add a new one without changing an old one. But anyways, keeping this all how it is. Let's go ahead and on our player here, let's review some of the components that are already on it. So everything that moves probably needs a rigid body 2D, most likely, if you're using physics to move. And then box collider 2D, this is what gives it collision. We have our player input component. This is a little bit of a different one. This is the one that actually lets us receive our inputs. The Unity 6 input system is a decoupled like mind frame of how you code things. Now what that means is how you would normally in the old version code something like what we're going to do today is you'd make a script. In that script you'd say, if the player presses the attack button, then start the attack. But in our script, we already assume the player pressed the button because the player input component's only going to run the code if they already did. And this decoupling allows us to make our game work in a variety of gamepads and with a variety of like touch screens and stuff like that. So our player input component here, only thing we've changed is we made sure our actions is set to the default input actions here. And we've made sure that under behavior, instead of send messages, it's invoke Unity events. We also have a top-down movement script. Again, not necessary for this video. Sprite render and transform came with the square. Sprite render controls the color and other rendering related things, and the transform, which has position, rotation, and scale related things. Okay, let's actually write the script now. We have a little bit of background. Well, actually a little bit more background. If you haven't yet, you should have a scripts folder in your project. You can right click and then do create folder here and then call it scripts. Now the reason I say that is there's two ways to make a component in Unity. One, you can go inside of a folder like this and then right click, create mono behavior script, or on your object, you can click Add Component and type in the name of the new component you want to make. In this case, I'd call it like spawn hitbox, because we're going to make our script very generic. But if we make the script in here, it's going to actually put the script in our assets folder, which we don't want. Because if you're organizing your project well, you should have a scripts folder for all your scripts, and a sprites folder for all your sprites, and etc. If you're organizing it even better, you should have different folders for each person on your project. That way everyone knows not to touch each other's stuff. We're going to go into our scripts folder and make the spawn hitboxes scripts. I'm going to right click and then do create, and then mono behavior script. I'm going to call it spawn hitbox. Spawn hitbox singular. No spaces. Never do any spaces. Ever. It'll break it. After the script's made, I'm going to open it up. Now, I might go fast at some points in the video because things load for me immediately because I already had it open. If I'm ever going too fast, you can always slow it down or pause it or rewind it. If we're going too slow, you can always skip or speed it up. But I would not recommend that part because you might miss information. Even if you're experienced, you'll probably learn a thing or two from these videos. Here's a spawn hitbox script. I'm going to go ahead and just add it to the player right now. So I'm going to go back to the player and drag in the spawn hitbox. Actually, back to the video meta stuff. I recommend watching all of these videos. Even if you already know how to do a thing, again, you'll probably learn something. And also in each video, I do something a little bit different, like putting the script on immediately, or going into debug mode or something like that. You'll learn a lot from watching each of these videos individually. Highly recommend it. Even if you're not the one putting the thing in the game, watching the video, maybe even just having it on your second monitor while you code, can be a really, really good resource. Or while you're doing art or something that you can have background noise for. Anyways, player here. I'm minimizing the components that we're not using, which is actually most fun. Player input's big and spawn hitbox is big. I dragged spawn hitbox on while I was talking. Back to the code. So the way this works is we have a void start and a void update. At this point, I've said this 3 times today. Our void start is all the code that you want to only happen at the very beginning of the game. This is like initialization or setup stuff. For example, this is where you'd put like player health getting set to the max health, enemies going back to their spawn points, stuff like that. Void update is for stuff that gets called every single frame, all the code that happens all the time, like looking for inputs, applying physics, taking damage like a poison or something like that. You wouldn't want to put code that like set the player's health to the max in void update, because then every frame their health would be getting reset constantly. And you wouldn't want to set code that looks for things like, that does things like updates physics positions, because it would only happen once at the very beginning and nothing would ever actually happen in the game. We're going to create a new void and we're going to plug it into our input system. So we're going to write public void and we're going to call it attack. And in the parentheses, we're going to type in input action.callbackContext CTX and write curly brackets. Again, sometimes we'll go fast. This is a method or a function. It's called attack, and it takes a single parameter or a setting or an input or whatever called CTX. This gives us information that we can read about the input. For example, we can access when the input was performed. We can access if it was canceled. We can access how long it was performed for. We can say, we can read the value from it, which is the most important thing. There's a bunch of stuff. Right now, we're actually just going to write debug.log and in parentheses, quotation marks, attack. This is a line of code that will put a message in our Unity window that we can read for debug purposes. In this case, before we actually write any attack code, we want to make sure this function works at all, because you want to test your code out periodically. You don't want to be coding for hours and then test at the very end and realize nothing works, because then you've got to go through hours worth of code and you've got to figure out where the issue is. You do the constant testing, you'll find the issue immediately and save yourself a lot of time and a lot of headaches. Back to Unity. Spawn hitbox thing here. We need to actually plug it in now. So in our player input component, we're going to click the events drop down here, and and we're gonna click player, and then we already have the callbacks from the other video. There's one called attack callback context. Click the plus button there, and then we're gonna drag our spawn hitbox into this none object slot that was created. And then instead of no function, we're gonna change it to spawn hitbox attack. So our code is decoupled. Again, back to that word, decouple. It means that everything is separated. Our movement code is different than our attack code, which is different than the component that's actually looking for each of those inputs. You'll see that in this player input component, this is almost like a master component for this object, it's doing things in both the top-down movement code and the spawn hitbox code. This is really, really good because it makes it easy to make characters that can move but not attack, and vice versa. It also makes it easier to debug because if the scripts aren't talking to each other, then you know that if there's an issue in one script, it can't possibly be related to another script. And then if this script's broken, we only have to review this much code. And if this script's broken, we only have to review this much code. Anyways, let's go play the game, see if it works. Input system, by default, the attack button is set to enter for some reason. So to check this out, right now the project window is open. Let's view the console window and press enter. You'll see the number went up. It's also set to left click. This is weird. If you want to change it, you can. So we have the regular attack thing built in. We can see it prints the message. Now that we know our code works, we can actually write code that does something useful. What we're going to do is we're going to write what's called a box cast. Or, yeah, let's use a CircleCast actually, just because it's a little easier to comprehend. So there's collision in Unity, right? There's the box collider, which allows you to check for collisions with things, and you can not pass through them, so you can fall on the floor and not fall through the floor. But a box cast or a CircleCast, there's a lot of different cast types. This is going to let us, on one single frame, do a check and then do something with that information. So I'll show you what I mean. In our attack function, what we're going to do is we're going to write physics 2D dot CircleCast, which is a function. And in parentheses, there's a few things we can do here. We need the origin of the CircleCast, the radius, and the direction. The origin, what we're going to do is we're going to make it just the player's position, I guess. So transform.position is how you access the position of the game object this script is attached to, in this case the player. Then we say comma. For the radius, I want to say 1.5f because I want it to extend on one unit on both sides. So if 1.5 is the radius, that means 3 is the diameter, and the player's diameter is 1, so it extends on both sides. The direction, I don't want the direction to be set at all, so we're going to say vector2.0. And this is the most very basic CircleCast. Now the issue with this is that we're doing the cast, but not getting any information from it. We're not doing anything with the cast, we're just doing it. So where it says CircleCast here, if I hover over it, you'll see that it says raycast hit 2D. That means that this returns a variable of type raycast hit 2D, which the raycast hit 2D has some information in it, like the point of collision, the distance to the collision, stuff like that. Let's go and let's use it. Before the word physics 2D, I'm going to type in raycast hit 2D, and we call it hit. So we're creating a variable called hit that's equal to our CircleCast, which means that as soon as we attack on that frame, it's going to create a CircleCast that's at our player's position, that's bigger than our player, and it's going to put all that information into a variable called hit that we can then use to see information about what we hit. Before we do anything else, I actually realized what we did here, we wrote 1.5f. This is what people call a magic number. And despite the name, it's actually not a good thing. Because if you just read the code, like if you're just a person looking by the code, you don't have any clue what this 1.5f means or why we chose that number. So typically to fix magic numbers, what you'll do is you'll create a variable. So let's do it real quick. In our spawn hitbox code up here, we're going to create a public float called attack radius. And then we're going to give it a default value of 1.5f. And then later on in our attack function, instead of 1.5f, we'll say attack radius, because attack radius is 1.5f, so they're interchangeable. In the other video I mentioned it, so I'll mention it here too. A public float is one that can be seen from everywhere in your application. So if I go back to Unity, we'll see that Unity can actually see this attack radius float, which means a number. We can actually set it to something else. If a variable is not public, if you just write the variable float here, it is by default private, which means that only this script can see the variable. So now back in Unity, even Unity can't see the variable. Not writing anything at all is the same as just writing private like that. If you're using if you're making a variable that's supposed to represent some sort of setting in your game, you should always use public. Technically, there's a better way to do that, but that's more advanced. And then this value after the equal sign is the default value. This is just what the value gets set to whenever you add the component to something or click the reset button. Whatever I set the value to here is the actual value. It's not going to be 1.5. In this case, it'd be 4.3. This is just the default. Okay, one last thing for this step anyways. In the attack function here, we want to see if it hits something. So here we're going to say if hit, and then we're going to say debug.log. We're going to say ow. Whenever you're writing text, like plain text, you have to put it in these double quotes here. That's called a string. If we hover over debug log, it says object message. A string is a type of object. So what our code here says is draw the circle cast at our player's position with the given radius, and if it hits something, then write this little message to the console so we can test it out. Let's play the game and see what happens. If I click, it says ow, which is a little mysterious. Why is it saying we hit something? We didn't put any enemies in yet. We're hitting the player, that's why. We need to add a couple of things to fix that. First, let's talk about layers. Every object by default is on the default layer. So with my player selected, you see it says layer default here. There's 5 default layers in Unity. Let's add an enemy and put it on a separate layer of its own. So we're going to click the plus button here, 2D object, sprites, square, and then let's change the sprite's render color from white to red so we can notice it's an enemy. Let's rename it from square to enemy so that we have some good habits being formed. Don't ever leave the default names, ever. Unless it's main camera or global light 2D. Now the layer is default. Let's change that. Let's click the default layer and click add layer. We're going to call this enemy. This version of Unity seems to have a bug with the layer manager. That is fun. Am I going to have to add this? Okay. That was very weird. With the enemy selected, the layer can now be changed from default to enemy. So code is not magic. This did not just magically give it enemy abilities or anything like that. It just told it it's on this arbitrary layer called enemy that we can now do stuff with. In our code, what we're going to do is this CircleCast function, we can give it another property. After the vector 2.0, if I had a comma, we'll see that we could also give it a distance. We'll say 0 for the distance. After that, we can give it a layer mask. This is what we want. There's actually 8 versions of the CircleCast function. There's origin float radius, origin radius direction we used earlier, origin radius direction distance. Then there's the one that has a array of results. We can see if we hit multiple things. There's a lot of stuff here. We're using this one. Now it wants an int. Float, I didn't mention this earlier, is a decimal number that can have like a 0.5 or a 0.2. An int or integer is a whole number, so it can only be like 2 or 3 or something. In this case, if we go back here, it looks like the layer number is 3, but that's actually not the case, because the layer mask is different than an int. But luckily, C# and Unity actually has some code to translate it for us. So watch this. Under our public float attack radius, let's add a public layer mask and call it attack layer. Let's not set a default this one. And then after the 0, comma, we're going to write attack layer. Now this looks a little inconsistent because this is an attack layer, and a layer mask. You notice earlier, if I hover over CircleCast, our float radius here, the second parameter, we had plugged in another float. But for this parameter, it wants an int for our layer mask. We plugged in a layer mask. The reason that we can plug in a layer mask where it wants an int is because the layer mask object, just watch, actually has an int called value where it can automatically, implicitly convert itself to an int when it needs to be one. Anyways, that's just some technical jargon. This public layer mask here, let's go back into the code, or back to Unity, I mean. We'll see that on our player now, in our spawn hitbox script, there's a second setting called attack layer that by default is set to nothing. If I play the game now, since it's still set to nothing, and I attack, that debug message we wrote is never going to happen because nothing is on the nothing layer. There is no nothing layer. But let's change it from nothing to enemy. And by the way, this is a layer mask. Whenever you hear the word mask, that means you can have multiple selections. So I can say everything on the enemy layer and everything on the default layer if I wanted to, and have both selected at once. In this case, we don't want that. So attack layer set to enemy. Let's click on our enemy, make sure enemy is still on the enemy layer. This looks like it's set up right. Let's try it out. Now, if I click or use the attack button, nothing happens because the enemy is outside the radius. Let's move closer to the enemy and press the button now. Now, still nothing happens. That's one more thing I have to do with the enemy is the enemy actually needs a box collider of some sort if it needs to receive these collisions. If I go back to the code here, hover over CircleCast, it doesn't tell us this, but this will only interact with objects with a collider. So let's go back to Unity and let's give our enemy a box collider 2D. Let's try it out one more time. So just click, press enter, nothing happens. Move close enough to enemy to where it's in our radius. We click and the message pops up. So now it knows that it hit the enemy. A few more things we're gonna do. One, this is actually really hard to know if it worked or not. Or if I change the radius on the player, we don't really know how big this new radius is. We can do the math and find out. If it's a radius of 5 and this is 1 unit, each of these squares is 1 unit, then 1, 2, 3, 4, 5. It should be in the radius now. But we don't want to do math. We want to just look at it and see. We're going to take a little detour from this script, and in the same script actually. We're going to do something called gizmos. Gizmos allow you to visualize anything pretty much. And what we're going to do is we're going to visualize this circle here. So under our public void attack, we're going to say on draw gizmos and take the autocomplete here and make a private void called on draw gizmos. In here, this is where we can write gizmo code. So we're going to write gizmos dot draw wire sphere, and in parentheses, the center and the radius. Go back to our CircleCast, origin radius. Let's just copy the one from before and paste it in here. This will now draw a circle that we can actually visually see at the same position as our CircleCast with the same radius as our CircleCast. Let's try it out. Immediately you'll see a little circle got created. This is really, really helpful for debugging. I can in real time see how my attack radius gets changed, and when I play the game, I can actually still see it. Just make sure that if you want to see it, you click this little gizmos button in the top right. Very, very helpful. Because now we'll see that not until it actually immediately enters it can I attack it. It's very, very accurate. Of course it is, it's a circle. Okay, that was a very quick detour. Now let's do a little bit more with this. We're using hit like a boolean here. This if statement, what we do is we write a true or false statement inside the parentheses, and if it's true, this happens. Now, our true or false statement is just that we hit something. What we're going to do is we're going to get some information about what we hit that's stored in this variable. And to do that, instead of ow in quotation marks, we're going to type in hit dot, can we do game object? No, we can't. Dot collider dot game object dot name, which sounds like a lot, but it just means whatever we hit, get its collider, then get the game object attached to that collider, then get the name of that game object. This is more debugging to make sure we actually know what we're hitting. You and I just watching, playing the game, the video, whatever, we know it worked. It's pretty obvious it worked. But when you have a game with dozens of enemies and lots of things and lots of layers, you want to debug this all the time. So let's try it out now. If I click, it says enemy, which is the name of this object here. If I rename it to enemy2 and do it, it says enemy2. So we know we hit the enemy now, which is great. Now, let's, a couple things bothering me about the script. One is that it's like all over the player. I could be like facing completely away from the enemy. I click the button and the enemy just would not take any damage. I mean, sorry, it would still take damage, which is not really ideal. We want to look at the enemy and kill it. So what I want to do is we're going to keep track of like the last direction we faced, which is going to be a little bit weird because it's going to break a little thing I keep saying. This part is actually going to rely on the movement from the follow movement, the top-down movement video. Because this follow movement script, this top-down movement script already has a really convenient variable we can use for seeing like what direction we're facing. Like this variable is already being used. It's very convenient. It would be very like waste of code to like basically rewrite this whole thing when we already have it. So in our spawn hitbox code, we are going to write code to access the top-down movement code. If your game uses a different top-down movement, I would update it to this one now because this one is going to work much better with this, unless you really, really, really know what you're doing. So let's do it. In our void attack, we want to do is basically say, take the position of the CircleCast and offset it based on what direction we're facing. If we're facing up, then offset it up. Facing down, offset it down. It's going to spawn the circle in a different spot. We're going to do the same thing in the on draw gizmos here. To do that, after transformed opposition, we're going to say plus get component, and then in angle brackets, we're going to say top-down movement. And then at the right angle bracket, we're going to add parentheses, and we're going to say dot, and our variable name was called movement. So we're going to type in movement, and you'll notice that it doesn't work. If we hover over it, it says top-down movement is inaccessible due to its protection level. That's because we set it to private in the other video. The reason we did that was because it wasn't a setting. We didn't want to set it inside of Unity. If you make it public, Unity is going to see the variable. Your users are going to see the variable. Your teammates are going to see the variable. And they're going to think it's something that they can set when it's not. It's not game breaking, but it's very misleading. So I don't want to change it to public, but I can't keep it private. So what I'm going to do is I'm actually going to change it to public. But before the word public, I'm going to add square brackets. And inside those square brackets, I'm going to type in hide in inspector. This variable is now accessible from other scripts, but you can't see it inside of Unity. This is the best of both worlds in this case. There's another case where you don't want other scripts to see it, but you do want Unity to see it. For example, these variables, walk speed, run speed, there's no reason any other script should need to see these. So what we can do is instead of public, we can say private. And before that, in square brackets, we can type in serialized field. This is the best of both worlds in the other way. So it's basically 4 outcomes. Think of it like a grid or whatever, or a chart, a square. There's the public variable, and the private variables like the x-axis or whatever. And the y-axis is, do you want to see it in the inspector or do you not want to see it in the inspector? And those are the 4 options. There is the serialized field private, there's just straight up private, there's hide in inspector public, and there's straight up public. So those are the 4 different ways you can kind of do this. You should always be using these. This is basically the best way to do it. The hide inspector private is 100% the best way to go. And then if you want it to be seen by another script but not Unity, hide inspector public is the best way to go. I meant serialized field earlier. 100% use serialized field private and hide inspector public whenever you can. It's the best coding practice. Okay, let's go into the spawn hitbox here. And we're getting a little issue because transform.position is a vector 3 and movement is a vector 2. To fix that, before all of this here, we're just going to say vector 3. And now the CircleCast is going to be offset by 1 unit because by default our movement variable is being set in units. It's going to be offset by 1 unit based on the direction we're facing. Anytime we update our CircleCast origin, let's also update our gizmos center. Okay, I'm also going to get rid of all of this because we don't need, actually we're going to need start later, but we don't need update. Back to Unity. Let's watch the circle move because we want to, again, test a lot because there's going to be something wrong with this actually. When I move, you see the circle goes actually the direction the player is facing now. It actually looks perfect. When I stop moving, it gets reset. That's because this movement variable we created actually resets to 0 when we're not moving because it's an accurate reflection of our movement. It's not our direction. We should actually have 2 variables here. We should have movement that resets to 0 when we stop moving. We should have direction that doesn't get reset. So what we're going to do is the whole private hide inspector public thing, change it back to private. But instead, we're going to make another variable under these 3 that's going to be hide inspector public. This is going to be a vector 2 called direction. And then in our void move here, we're going to say direction equals ctx at read value vector 2. But we're going to do one small thing here because we just kind of recreated the same problem just with a different variable. So what we're going to do is we only want to reset the direction variable if we're moving. Our ctx here is going to have a different x and a y value based on whether we're moving or not. In our direction here, we're going to say if ctx.readValue vector 2 is not equal to vector 2.0, and then add curly brackets and put this inside the curly brackets. I'm holding down Alt and pressing the up key to move the line. So remember the move function here, it gets called every time we start the input and we stop the input. We stop the input, that means it got reset back to 0. But this code is basically saying only set the direction if the value is not equal to 0. The exclamation mark means not. So this direction variable here is just like our movement variable because it gets set inside the move and it gets set based on ctx read value. But the difference is that it will never be 0 ever because we're checking before we set it to make sure that we're not setting it to 0. Back to our spawn hitbox, we're just going to replace both instances of movement with direction. Back to the Unity. Let's see how this goes. We are almost done. We're going to have a very basic, we hit enemy's just going to like immediately die. Because in another video, we're going to talk about stats and stuff like that. Let's see. If I move the player around, we'll see the box now moves in front of the player, does not get reset. Little issue is the box does start on top of the player. What you can do in your code here is you can give it a default value. Like we can say vector 2.down or vector 2.left or vector 2.right or whatever. I'm gonna do down because I'm gonna assume that most of your guys' characters are gonna be looking down by default. Whatever direction your character is moving by default is what this should be. If I play the game, that may not actually work. No, it didn't actually work. I'm a little surprised. Okay. I lied. Actually, we're going to put it in the wake function. We're going to say direction equals vector 2.down. I'm going to adjust the spacing here a little bit. Okay. That didn't work because it was a public variable. If it was a private variable, it would work just fine. Yeah, now you'll see that it's down by default. And then we can still click detect enemy here. And you can imagine a sword swing animation or something like that. Let's do the last thing. We're gonna optimize this because we're using get component twice. It's redundant. And we're going to actually make the attack do something. So this get component here, every time we attack, it's gonna find the top-down movement script on the player and get the direction. Every time it's finding it. What we can do is we can say, only find it once at the very beginning of our game and then cache that into a variable that we can use later. It's a little bit easier to read and you don't have to type this so many times. So what we're gonna do is, under these two variables, we're gonna write private top-down movement, I'm gonna call it top-down, like that. And then in our void start, we're gonna say top-down equals get component top-down movement. Since top-down is the same thing as get component top-down movement, then we can replace all of our instances of top-down movement with top-down in these parts of our script. So now, every time we want to reference our direction, it's just top-down dot direction instead of get component top-down movement dot direction. And then, like in the top-down movement script, instead of void start, we're going to say void awake because all of our get component code should happen in awake instead of start, just because awake happens a little bit before start does. This is going to work the exact same. I don't really need to show that. We're going to make it so we debug log the thing and then hit the thing. Like we're just going to kill it straight up. Now, obviously, you'd probably want a stat script or something. Again, that's going to be in another video. Under the debug log here, we're going to say, so how do you destroy a game object? Good question. You type in destroy. And then in parentheses, hit. Now, destroy is a little weird. Destroy can destroy a game object, component, or asset. What that means is that if I say hit.collider, that's going to just destroy the collider on our game object, which is a little odd. If I say hit.collider.gameObject, it'll actually destroy the game object itself. What we can also do is after this, do comma. The second parameter is t for time, which is how much time there is before destroying the object. Maybe you want a half a second delay, a full second delay, something like that. In this case, I'm going to add a 0 second delay. I want it to die immediately for the player feedback. But for a polished game, we'd probably have is the enemy flashes red for a second and then dies. In which case, you probably have a half a second delay, is what I would think would be a good amount of time for that. Anyways, let's see what's going on here now. Move around, I click, nothing happens because it's not in the range. I get an enemy within range, I click, and enemy dies. Perfect. Let's take an enemy and let's just like make a bunch of them. If I hold down the enemy here, and while I'm still clicking, dragging, holding down, Control D, I can, was it Control D? Maybe it was just D. And Control D, I can like paste them a bunch onto the map because I'm duplicating the one that I'm currently dragging. Let's try it out now. Play the game and I can click and just kill all the enemies now. That can be a little like thing. You'll notice that this is very generic. These don't really look a lot like enemies. I could go and I could give them all a follow movement script that I made in the other video. We'll say they're all following the player. They're a little more enemy-like now. This is obviously not necessary. Oh my gosh, they're really fast. Let's see. That's better. Oh my gosh, they're still really fast. Why are those ones? Oh, I didn't have them selected somehow. Anyways, so these guys are a lot slower now. Obviously, I just set the speed lower. And they feel a little more enemy-like now, although it's a little boring because they do all eventually get into one position. But I guess the right side is I can now go boom and kill them really quickly. You'll notice they didn't all die immediately. There's little quirks with our solution. This function's happening once when I click the mouse, once when I release it. And the CircleCast can only hit one thing at once because our code only supports one thing at once. So if you have a bunch of enemies at once, you're not going to kill them all. There's ways around that by using CircleCast all, which returns an array or a list of all the things you hit. Then you can go through that list and say, for each thing in the list, destroy it. But we're going to not talk about that because it's not necessary. yeah, that's pretty much it for the video. This is a very, very simple like attack script. Not going into too much detail with like the with a lot of the melee stuff, but just want to keep it simple for this video. You can implement your own animations and enemy code and stuff like that, because that's not what the video is about. Again, these videos are supposed to be specific gameplay features. If you want videos about animation and stuff like that, there's lots of resources online for that, and eventually there's going to be the things posted on the website. Yeah, thanks for watching. Go ahead and watch another video.